successful business as the simulator business is or the computer games is. One reason is technical complexity. In order to make an as accurate as possible 3D version of a nautical chart is something that requires deep understanding of maritime. It requires a deep maritime knowledge and deep technical knowledge. Unfortunately, not enough research is being done currently on this subject. Hence, part of my project is to create awareness about this gap in the academic research. There is a justified conservation and related. There's just a conservatism of the industry. This is in part because the maritime industry is more prone to accidents than any other industry, and usually those accidents have very catastrophic events. So for something to be established and be considered safe for navigation, it has to be battle tested, rigidly battle tested. There are legal reasons as well. Lots of rules and regulations set by IMO, etc. And there's also a very high cost of getting the data available to recreate a 3D map, which means it requires extensive bathymetric measurements, satellite measurements, and LiDAR images, which is basically scanning the ocean with laser arrays, etc. And plus, as we already mentioned, there is a lack of experience in the scientists who actually are into 3D creation, 3D visualization. They don't know anything about maritime navigation. So there is a knowledge gap between those two fields. So, but on November 2014, quite recently, three scientists actually decided to tackle this issue, and basically they proposed a method to generate a 3D depiction of eddies based on the digital Earth. What they did basically, they used the digital Earth's distributed WebGIS infrastructure, and in order to make use of the rich data included inside an S57 ENC. And that way they used to recreate a 3D visualization of the Yangtze seafloor. I'm skimming through those because I'm going to explain them in depth later. So, but I just want you to get an idea of what's coming next. On top of that, they also proposed a web server client system that can actually be implemented both on board the ship and into the port authorities. So when the ship approaches the restricted water area, this system kicks into gear and helps the mariner navigate its vessel. So, what is a geographic information system? Well, a geographic information is a computer system for capturing, storing, checking, and displaying data related to position on Earth's surface. That's according to sector. One of the major features GIS provides is an advanced visualization that allows the user to understand better pattern and connection between data and geographic locations. Some examples of GIS are actually used by research to examine ice melting or crime data rate per region. For example, here is a Washington DC vehicle crime hotspot hotspot map. It's based on hotspot analysis done using the ArcGIS software. Also, GIS systems are also used to produce three-dimensional images. So, what is WebGIS then? Well, WebGIS is basically a delocalized and decentralized GIS system. So here we again. Here we have a relational database that includes the information about basically the location information, all structured according to an SQL, all structured within an SQL database or any other kind of database format which is useful. Then it's been transferred into an internet map server, which is usually provided through major GIS suppliers like like for example the CrimeStat or the ArcGIS companies, and then all this information is passed in a second tier through a traditional web server, through the internet and through the client, and to the first tier, which are the clients, basically a web browser, our mobile phones, any recipient's device. Okay, so WebGIS basically has helped in three specific areas: spatial and data access dissemination, spatial data exploration and geo-visualization, and spatial data processing, analysis, and modeling. So, what about Digital Earth? Digital Earth is a global effort to construct a comprehensive virtual model of our world. It was established by Al Gore in 1998, and it enables an in-depth comprehension of the global changes, thus allowing us to understand regional phenomena caused by the Earth's rotation. Of course, it has evolved beyond that, and right now it's being used for many applications, one of which is the one I'm going to present further ahead. So, going back to the 3D80s application. This is the data fusion model. They actually, those 3D scientists have actually come up with how to use the Digital Earth's reference model to infuse the ENC nautical chart data and reconstruct the sea and provide an accurate 3D depiction of the Yangtze River. They proposed, sorry, some technical issue.
How is the data fusion done? The 3D data fusion?
Yeah, actually it's been done in 7 stages, which I'm going to, so
you might have to do it from the keyboard.
It's a very old-fashioned.
Feels very old-fashioned.
Yeah.
Ah, it's good now. Now it's come. It's come.
It's coming. Okay. Good. Okay. So, I'll come here.
Did you in fact pay David to ask that question? How is it done? And then
it's actually it's a nice pass actually. So they propose this data fusion to be done in 7 stages. So the first one is is creating a latitude-longitude grid model to create the Digital Earth model. The second phase, they create a multi-resolution pyramid model to organize the terrain data according to their characteristics, basically using bathymetry, basically the formation of the rocks, etc. Remote sensing image data has to also be implemented into this multi-pyramid model. At this stage, all the information included into the XML file of the ENC need to be extracted and fused into the Digital Earth model, which is basically navigational data like contours, constant lines, anchor zones. So afterwards, the 3D visualization needs to be created using tools such as 3ds Max or AutoCAD or any. They don't restrict you. The authors don't restrict the tools to, necessary for it. Can actually use a video games graphic engine. But in their case, they used the 3ds Max to recreate the water and the landscape. Of course, since this is meant for navigation, a Mercatoric projection needs to be constructed. So this is done in phase 6. A Mercatoric projection is basically converting from the Earth's spherical coordinates in a 2-dimensional flat surface. And finally, the 7th stage is basically having the final fused model ready for use. So, how do they actually put this thing together? This is the architecture of the system they proposed. So, the web server, the server part. The server part relies is being installed on the Port Authority side, and the client side is being installed on board. By internet, they mean the Wi-Fi connection that exists in all major and busy ports around the globe. And this can actually be utilized freely as soon as the vessel enters the port. So, the client side is built on Java, WebStar, and component technology. It's comprised of 3 modules you can see at the clients, display, control, and communication. It is in charge of the display modules are construction and display of digital Earth image. Basically, it's what we have built before. The control module is actually the user interface. And a communication basically handles the communication between the client and the server. So on the server side, it's straightforward. It's a ToCAI word server. It exchanges data through a Java network launching protocol and HTTP. It's servlet. It's the most interesting part, which is it includes all the databases, which is the chart databases, the overland spatial database, the image databases, the 3D model, and various other web servers. The data processing is actually employed to process static geographic information data. For example, the pyramid models we mentioned earlier. A caching module is also implemented, so a more efficient use of network can be utilized. Something that's very important during the limited computing resources that are on board the vessel. So, some examples of the work done so far. This is an early reconstruction of the Yangtze bottom. This is actually the result after the phase 4, which they actually used the sounding data. And this is the final outcome. Here you can see the green lines represent the safe depth counting, which is basically the areas where the water becomes shallow and it's not safe for navigation. And they have actually recreated the indicator as well. And this is the zoom out view of the Yangtze River after all the data has been infused into the Earth grid model. So compare it with the earlier view we had of the digital representation of the traditional eclipse. Compared with that, even if it's zoom out, you can already see there is a depth, there is much better graphics quality. So the concept is that this is the zoom out view, and when you enter the actual receiving water area, it goes into this mode, and you can actually navigate having a much better awareness of the area. So, at that point, our empirical research needed to start, and we needed to actually find out what the industry thinks of this solution, of this research. So, we chose to, as our research sample, we chose the Greek industry, being the number one ship owning country in the world, and having the most technological advanced fleet currently. We decided to conduct our research there. So the way you conduct our research is called triangulation. It's basically a combination of methodologies to study the same phenomenon. It was introduced by Denzik in 1978, and it's been used by researchers for years now. There are various kinds of data triangulation, of triangulation. First of all, it's the data triangulation, which is what this research uses. The investigation triangulation, the theory triangulation, and the methodological triangulation. There's no point in going further into that because we're running a bit late. So, as I said, this is the method we use. So we basically use both qualitative and quantitative data to conduct our research. For the qualitative part of our research, we used interviews, which was 7 interviews among 6 companies. And here you can see basically the nature of the companies and the role of its interviewee. As you can see, there is a variety. Even though the majority of the people are operational people, there are also a field manager and engineer, and also actual captains. Of course, we had a chance to actually interview one ECDIS manufacturer, which has a branch in Greece, as well as a global maritime service company. However, due to the nature of the interviews and the nature of the shipping industry, which is reserved, I would say, they required us to be anonymous. So the data is at my disposal and can be shared for academic purposes, but I cannot present them in this presentation, unfortunately. So, 7 questions, ranging from a generic to a specific format. In short, like, why ECDIS? What was the reason behind the adoption of ECDIS? Why is it so important? How has it helped so far? What features? What are its features that have helped so far the navigation? Is there really a problem with the information visualization? And how can it be improved? And finally, do you believe that 3D depiction is a solution to these problems? So basically, we're trying to get a feedback from the actual people within the industry. What do they think about ECDIS and where it's going, and what do they actually want out of it? So the analysis involved traditional qualitative research analysis. First step was, since the interviews were conducted in Greek, and they were recorded in an audio format, first they need to be converted into a text format, then translated from Greek to English, and then a thematic analysis needs to be carried out. We used the method proposed by Brown and Clark, which is a 6-phase method. The first phase talks about getting acquainted with your data. This has been done thoroughly through transcribing and translating. The second phase in open coding is basically assign non-predefined codes to any information within the text that appears relevant to our research. Thus, we ended up with 52 codes of recognized within 7,000 words of interview text. Third part was create the initial theming. So the initial themes, as you can see, are reasons, features, contribution, limitations, visualizations, improvements, suggestions, and 3D expectations. What do you expect out of 3D? We further categorize them per person, so we know exactly what each person says, and per company. Yeah. So then we refine those themes by merging similar themes together, discarding the ones which are not related to directly to the research question, and we also provided the explanation for its code, so it's more humanly understandable. We ended up with 5 final themes. As I said, irrelevant things were discarded, and related themes have been merged. So, at this point, the phase 5 says you need to re-examine your data and see if they actually tell the story. For that, we had to create a traditional manual. So, based on our interviewees' answers, do their data the data tell the story so far? So apparently they do. So, EGDIS. The reasons behind it was a quick and safe. This is actually statements from the interviews. We didn't tell them anything to do. We just asked them those questions, and there's all things came out of their own mouth. And as expected, it matches the findings of the literature review. So, quick and safe decision support tool, contribute to economic development of the industry. Because of the port traffic increase, there was a need for a paperless bridge initiative. Why was it useful? Why is it useful? Because of these features. It can act as an alert tool. It provides real-time monitoring position. It can create an optimal course planning, thus minimizing fuel consumptions. However, there are limitations. So, insufficient trained officers, user interface fragmentation, inferior visualization of EMC data. Those are all findings we actually already seen in the literature review, and it was a very pleasant surprise to actually hear them from the people in the industry. So at least there's no research gap there. There is a need for EMC quality assurance. There needs to be more control over the data. As Dr. Martin said, what if the data are incompatible with each other, or there is a consistency? There needs to be more control over the quality of the data. Some suggested that the screens, the monitor screens need to be increased, because they're actually 19 inches screens, while traditional paper chart is as big as this table. So that creates a little bit of an issue for the officers as well. Interface standardization. Right now, every EGDIS manufacturer produces its own interface. So an officer who's been trained into one type of EGDIS, he can only travel with this one, with that one. He has to be retrained to operate another EGDIS. More confusion. They need to find a more. They didn't specify. They didn't specify yet, because we haven't introduced them with a 3D option yet. So, but they did recognize there needs an intuitive way of transmitting this information needs to be found. Oh, sorry. And so when they told them, when they introduced them to the 3D visualization aspect, they were actually quite skeptical of it, and they believe that this is what they think it will satisfy. It will provide visibility assist in bad weather conditions. Since the visualization will approach the real world, that will have situational and spatial awareness. It will be a most direct way of transmitting the information, and it will be easier to recognize dangers. This was actually came from an EGDIS training officer, and they explained us a phenomenon that's been caused during navigation within restricted area. It's called interaction. Basically, while the ship, or also known as bank sucking. So basically, yeah. So basically, while the ship travels, the water coming out on the side of the ship, has more creates a kind of turbulence that's stronger than the water that's on the side of the bank. So that creates a bit of a suction of the ship. So unfortunately,
Is this a Bernoulli effect?
I have no idea what a Bernoulli effect is. But yes, it sounds like it is.
A professor of AI has no idea what a Bernoulli effect is.
Well, neither do you, apparently.
so the way they explain as the interaction phenomenon is, it happens, they know why it happens, but they don't know until it's too late. So until the boat the ship stops responding to the wheel, they cannot know that they're under the influence of that effect. And after that, it's only one. There's only one way: crash with the. That's how most grounding accidents happen. So by 3D, they believe that seeing where the actual sea floor creates a slope, instead of just seeing a mark on a 2D map, can actually help the officer to understand that there's probability that interaction phenomenon might be created. So, so far so good. From that, we had to minimize our data a little bit more and basically isolate the parts which tell the story we want, which basically serves our research question, and of course write the final thematic report, which is in my dissertation, but for this presentation we can see it here. So, 3D visualization is going to provide a realistic error representation and increase situational awareness and spatial awareness, and will address limitations as loss of focus and confusion. And also, as a result, it will enhance current ethics by mitigating grounding accidents and increase navigation safety.
We can probably go to the conclusion because of
Yeah.
time constraints. But
Okay, fair enough. Quantitative research required certified questionnaires, closed questionnaires, I'll skip to that. This is basically just discrete statistics based on frequencies and percentages about causes of accidents, traffic congestion, bad weather conditions, area special characteristics, human errors, major causal factor. So, inference statistics, we also wanted to find out how spatial awareness is, if there's what's the correlation, if there is any correlation between spatial awareness limitation and accident causal effects, like human errors, and for that we had to create a null hypothesis. This is the process which we created a null hypothesis with, but since we're running out of time, I'm skipping through it. It was a big project, I understand. So basically, this very quickly, these are the variables that are correlated. We found out that are correlated with each other. So the constant variable is the spatial awareness limitation, and the variables we tested with was the traffic congestion. There is no correlation. The bad weather conditions, no correlations. For correlation to exist, there needs to be below 0. The approximate significance must be below 0.5. Area characteristics, extremely significant correlation. So spatial limitations of spatial awareness caused by the current two-dimensional chart effect is.
It can't be 0.000.
Yeah, No, it's actually, yeah, it's the way of SPSS.
What's the number? What's the real number?
It's 0.001.
Thank you.
So SPSS interprets highly significant correlations as 3 zeros, but they need to be interpreted as 0.0001. So with human errors, again, there is correlation and spatial awareness limitation with inadequate or false data from the system. It's basically what Dr. Barnaby said again. When the system gives us false data, we have a limited awareness situation. So, conclusion. Since it's a business, business
information systems manager.
Business information system manager, we're gonna use a business illustration, business decision method. So, the strength of this 3D visualization, it can increase spatial awareness. It can help identify dangers quicker. It can assist in accidents related to area characteristics, as found by the correlations. Predominantly are the grounding accidents. It can decrease frustration derived from information overwhelmed on 2D charts, as we already saw in this congestion screen we showed earlier. But unfortunately, there are weaknesses. It requires a rethinking of the procedures involved during approach conditions. By approach, we mean when the ship enters a restricted area. It might prove even more frustrating, especially for older generation of mariners who are still in active duty and they're having problem using even the typical computer. And unfortunately, all the solutions currently so far have never moved past the experimental or theoretical phases of development. Opportunities. Early adapters, as was the case with the 2D actives, early adapters benefited from a competitive advantage, and they're actually now in a very profitable business. It can create research momentum, and more scientists from various other scientific fields can enter the field of maritime information system development.
Sorry, by early adopters, mean people who make the systems.
Early manufacturers.
Early manufacturers.
Early manufacturers, basically.
They could research, they could provide funding for PhD positions.
Yeah, that as well.
Which
Threats.
is the purpose of life, obviously.
Reluctance of the maritime industry to adopt new technologies. We already said that is partly due to the high proneness maritime industry has in accidents and the catastrophic effects of these accidents. And the convenience of having a 3D visualization can actually increase the over-reliance we're already witnessing with the two-dimensional ECDIS, which means the officer will look more on the screen and not outside of the window. So, here are the references used for this presentation. Thank you very much. And if you have any questions...
Can I see your citations again?
Yes.
I was dying to see you actually have Al Gore saying.
Yeah, I actually do. I actually do. Wait, I need to set it again.
Actually,
And it's Al. Did I read that right?
those pictures of the Yangtze River were, I mean, it was actually photorealistic, right? It's underwater, but it's photorealistic.
Because they derive only from the sounding data.
Right, okay, so yeah. But then also, then you had the one that was just showing the channel in which... But when this was zoomed in, the image would be converted into the 3D visualization we saw later. Okay, thank you very much.
Thank you very much, and my apologies for the length.
No,
but it was a big project, and
You have another hour. You have another 45 minutes if you want.
well, that's the reason we have a...
So everyone ready for it? Grill him now. He's got a 45-minute question and answer.
For the benefit of the other BISM students in the room, this is a very good way to go about a project. Very meticulous thematic analysis of interviews. We don't often have students